So today I will discuss the addressing mode of 8086. So in the addressing mode of 8086, instruction performs a specific operation on the specific data is called operand, and the programmer must satisfy the operand instruction. The required operand may be placed in the accumulator or in the general purpose register or in the memory location. The way in which operand is specified is called addressing mode. That is, suppose we have write some program in the 8086. So you require the data for operation. Suppose you want to add 3 plus 5. So 3 and 5 is called data. So we need to data either store in accumulator or in any register or in the memory location. So how you call the data is called addressing mode. So that is you have to call the data for particular execution of the particular command. So there is a 6 way to first one is called register addressing mode. Second one is called immediate addressing mode. Third one is called memory addressing mode. Fourth one is called string addressing mode. Fifth one is called input output addressing mode. And sixth one is called implies addressing mode. So that is a register addressing mode, immediate registering mode, and the memory registering mode again divided into 5 types. That is called direct memory addressing mode, register indirect mode, based indexes, resistive relative, and relative based indexes. So first type of addressing mode is called register addressing mode. So in this type of addressing mode, data is in the register and instruction specified the particular register. For example, if I write move AX comma BX, so AX or BX is a register, that is a 16-bit register. That is we have to call that is you have to move the data of register B to register A. So this type of addressing mode is called register addressing mode. Second one is called immediate addressing mode. So in immediate addressing mode of operand is specified in the instruction itself. That is, the data is given in the instruction. Okay, so this type of is called immediate addressing mode. For example, if I write move AL comma 35 at, this is the 8-bit data because 35 you have to move 35H to lower part of the accumulator. Similarly, if I write move BX comma 0301H, it indicates 0301H data you have to move to the B register. It is a 16-bit data. Okay, so this type of addressing mode is called immediate addressing mode. So I told you memory addressing mode, that is when the operand is placed in the, when the data is placed in the memory. So memory addressing mode again classified into 5 types: register direct addressing mode, memory addressing mode, register indirect mode, based indexes mode, and register relative mode, and relative based indexes mode. So first you have to suppose any data or any operand is stored in a memory. So we have to, if I want to call this particular data from the memory, so we have to specify the address of the particular memory. So you know the address in the 8086 is just 20-bit of memory address. So the starting 16 MSB, this is suppose suppose we have as a 20-bit of memory address. So starting off 20-bit 16-bit, that is 16-bit MSB of starting address of the memory segment reside in the segment register, and the 4 LSB of the memory address is called effective address. What do you mean by effective address? That is the memory address of operand consists of two components: starting address of the memory segment and the offset. Okay, so 16 MSB of the starting address of memory segment reside in the corresponding segment register, and the operand memory location is within the memory segment from the starting address of the segment is called offset. And you know, bus interface unit generate 20 bit of starting address of the memory segment by shifting the content of segment register left by 4 bit. You have to put 4 zeros in the 4 LSB position, and offset is added to the starting address of the memory segment to get the memory address. That is, the memory address is equal to starting address of the memory segment plus offset. That is, the starting address of the memory segment is stored in the memory segment of that indicate the 16 MSB of the address, and offset is the 4 bit. That is, offset is given by the memory address. Okay, so in this way you have to call any data, or you have to that is move data from memory to ALU using the address. So address have the 20 bit, 16 bit of MSB is stored in the segment register, and the 4 LSB is stored as a offset. Okay, so in the memory addressing mode, first method is called direct addressing mode. So in direct addressing mode, the operand offset is given in the instruction as a 8-bit or 16-bit displacement element. For example, if I write AL, okay, 0301, so that means this instruction add the content of offset register 0301 to AL. The operand placed in the given offset 0301 within the data segment. That means we have to add the data whose offset is equal to 0301. Suppose you have one memory whose 16-bit memory. Suppose you have a memory, and suppose we have, but for particular block we have memory address is whose offset is equal to 0301, and some data is stored in this particular memory location, so whose offset address is equal to 0301. So now we have to move this particular data to the ALU and add with the 8-bit of lower LSB of accumulator. So this instruction AL add AL comma 031, that is the first data is stored in the lower LSB of AL, and the second data for addition is stored in the memory location whose offset is equal to 0301. Okay, so in this way you can directly call a memory address by offset. Second one method for the memory addressing mode is called register indirect addressing mode. Okay, so I am audible to you, everyone. I am audible to everyone. Okay. Second method in the memory addressing mode is called register indirect mode addressing mode. So operand offset is placed in any one of the register BX, BP, SI, source index, and destination address as a specified in the instruction. For example, if I write the instruction move AX comma in bracket BX, that is the address, that is the offset address is stored in BX register. So suppose BX register is equal to 03, that is the content of BX register is equal to 0301. That means you have to move the data from the memory whose offset is equal to 0301. Suppose in the memory whose address with offset is equal to 0301 95553 H. That means we have to move 9. That is we have to move 955H to AX, that is accumulator. Okay, so in this way, in first method, offset is directly given to in the instruction. In second method, offset of a memory address is specified any one of the register is called BX, BP, SI, or DI. Okay, so the for example of the register in direct addressing mode is called move AX, BX. Okay, so now the third method of addressing mode is called based addressing mode. So operand offset is the sum of 8-bit or 16-bit displacement and the content of base register or base pointer as a base register for the stack segment. So now the offset is equal to, what is the formula for the offset? Offset is equal to the content of BX plus 8-bit or 16-bit displacement. Example of based addressing mode is, suppose if I write move AL comma BX plus 05. Okay, so that means in the base addressing mode, offset is the sum of 8-bit or 16-bit displacement with the content of BX. So now suppose in the BX register we have stored 0301. Okay, so what is the current memory location? BX plus 05. That means you have to add 05 with the content of BX register. That is the current memory location is equal to 0306. Now that is the offset is equal to 0306. Now we have to call the memory whose offset is equal to 0306, and that particular memory, the content of memory location whose offset is equal to 0306 is moved to the lower LSB of accumulator. So in this way, we can call the data from the memory by adding some 8-bit or 16-bit data with the content of BX register or base pointer register. Fourth method is called index addressing mode. Okay, index addressing mode. Okay, so the operand of in the index addressing mode, the operand offset is the sum of 8-bit or 16-bit displacement with the content of index register, that is SI or BP, as a base register for stack segment. So that means in this addressing mode, offset or effective address is equal to source content of source index or destination index plus 8-bit plus 16-bit data. For example, if I write move AX comma SI plus in bracket SI plus 05, that means whatever with the content available in the SI source index, suppose in the source index the content is equal to 0301, so we have to add 05. So the current effective address is equal to 0306. Now we have to call the memory with if any memory if a memory whose offset address is equal to 0306. Now this particular memory from this particular memory location we have to move the data to the AX, that is to the accumulator of the microprocessor. Fifth method of the addressing mode is called based indexes addressing mode. Okay, so in the base indexes addressing mode, operand offset is the sum of the content of base register and the index register. For example, that is the offset address is equal to BX or BP plus SI plus DI. Example of the base indexes addressing mode is equal to move ax comma bx plus si in bracket. That is the offset of memory location is the sum of content of bx register plus source index register. Okay, so suppose in the bx register address is equal to 0301 and the si register 0301. So the current that is the you have to call the memory address whose offset is equal to 0301 plus 0301, and that particular data we have to move to the accumulator AX. Okay, so in this way we have to call the data from memory or from register. So those are called addressing mode. So any doubt in the addressing mode? Any doubt in the addressing mode? Now, next one is called, last topic of 8086 is called 8086 instruction. So I told you the 8086 instruction is similar to the 8085 instruction. I have already explained different type of 8085 instruction, how they operate with the data and their output. So now we have to move, we have to discuss some of the important 8086 instruction. So first of all, the instruction of 8086 is much powerful than the 8085. 8085 is called one address processor. Why 8085 is called one address processor? Because in 8085, suppose if you want to add data of accumulator with the register B, then we have to write add B. That is in the 8085 we have to assume that one of the data is stored in a accumulator and the addition of A plus B is again stored in accumulator. That is, we need to specify only one of the data, and other data we have to suppose to be stored in a accumulator, and always the result is stored in a accumulator. But in 8086 is a general purpose type of register. For any arithmetic or logical operation, all general purpose register act as a accumulator. So in 8086 we have to specify the both the register. For example, if you write add ax comma cx, it indicates the content of cx is added to the ax and the result is placed in the ax. That means we have to specify the address of, that is the address of both the operand. But in 8085 we have to specify only the address of only one operand. Okay, so it's called that's why 8086 is you can say that it is a two address processor. Okay, now if in the 8086 if I write add cx comma ax, so it indicates the content of ax is added to the content of cx and result is stored in a cx. So it's not necessary always the result is stored in a ax. The result can also store in a cx register, result can also store in a bx register. So that means if you compare with the 8085 and 8086, always in a 8085 stored result is stored in accumulator, but in 8086 result can store in any one of the register. And in 8086 we have to specify the both the address of the both the operand, that is both of the data. Okay, Now, some of the important instruction of 8086. First one is called move register comma register. So using this instruction, data can be transferred from 16-bit register to 16-bit register or from 8-bit register to the 8-bit register. Example of move register comma register, that is, suppose if I write move AX comma DX, that means it is a 16-bit data transfer. The 16-bit data that is stored in a DX register is moved to the AX register. Similarly, if I write move AL comma CH, that means the C of that is the of C register 8 MSB, that is most significant bit, is shifted to the accumulator low significant bit, because I told you in 8086 we have 4 register is called AX, BX, comma CX and DX. And again, AX is divided into 2 parts because AX is a 16-bit register. So AX is divided into 2 parts of 8-bit, AH and AL. Okay. So if I tell you AL, that means it is a 8-bit data. That is, you have to only move the content of AL, not the content of CS. Similarly, BX is again divided into 2 parts, BH and BL, CX, CS, CH and CL. So now if I write, that is the CH, just wait, CH, so CH and AL, that means the this particular data is moved to the AL. This is called 8-bit data transfer. Okay. Hello. Hello. I am audible to you. Now, second register, am I audible to you? I am audible to you.